Some of the more specialty application sensors and modes that we run into, you'll look at is color recognition versus contrast, clear objects, lasers, light sources. We start looking at color recognition. That becomes a little bit challenging for some sensors and things. Different colors reflect different amounts of light, so you have to change LED colors and things to help pick up those signals. And especially if you start trying to pick up the true colors of an object, we can do that with some more precise, more higher dollar sensors than you can with just some of the basic sensors. The other things where we see contrast and looked at sometimes is in color registration mark sensors. Pictures over to the right are some examples of color registration marks. You'll see a lot of times it's used for form, fill, and seal bags or things of that nature to trigger when to cut or seal the bag. You can look at like your toothpaste. That way they seal it. The label's always facing out. A lot of form, fill, and seal bag type applications. The second picture there is on a water bottle. You can see they had a mark there showing where to trim the label, where to seal the label back to. And sometimes that label, the mark is hidden within the colors of the product itself, within the same colors, just maybe a different contrast. That's again where you may have to look at using different color light sources to make the colors stand out more so than others. The most common light source is a red infrared, or red LED. But again, some of the contrast and registration mark sensors will actually vary the light sources. And then the bottom one is just a black registration mark. The another little bit of example, you'll see the registration mark sensors there, pictures of it. Some of the contrast sensors we'll see, or luminescent style even, is they'll use for grading types of lumber from that standpoint. One thing I will say with the color registration mark sensors, they're typically very high speed. A lot of times you're trying to trigger a very specific mark very quickly so that the machine can actually trigger on that point for a motion standpoint. One of the challenges we've talked about a little bit for photoelectrics is highly reflective objects and then also clear objects. So clear bottles, clear shrink wrap. The problem is a lot of times the photoelectrics themselves will see the object as its reflector or think it's seeing a reflector, and when it's actually the object you're trying to detect or sense. So that gives it a nuisance trip or false tripping. What happens on a lot of times with clear bottles, clear glass, is you'll actually have a standard photo eye. If you're using a standard photo eye, is the beam strength on it is so powerful that it will actually blow through the center of the glass bottle and won't see it. So what ends up happening is you'll have a double trigger. You'll trigger on the leading edge and then also on the trailing edge of the bottle, where if you're looking at the side of a bottle, you can kind of see how it would be darker through those areas. It'll pick those up, but it won't pick up necessarily the center of it. And then also, again, the shrink wrap, stretch wrap type applications pose issues. So what we do is they have some specific clear object type sensors. They have polarization filters built into them, again, to help you with fine tuning that down to sense those clear objects. One thing about a clear object sensor, a lot of times you can use it to detect other colors. So it can be used in place of detecting other darker contrast items. A lot of times what I'll say is to a customer is pick your hardest item to detect. If you're looking at clear objects, the thinnest, set up your sensor for that. And then everything else after that, it will be good. Usually it's the most translucent item is the hardest to pick up. So like shrink wrap or stretch wrap, if it's stretched real thin, it's harder to pick up than say a bottle or something of that nature. Or if you got a clear bottle, it's a little bit harder than a colored bottle. So usually if you pick the clear object, it's harder to pick up than like a brown or a black. One of the things as far as shrink wrap goes or stretch wrap on boxes or highly reflective type objects is if you can take the sensor and skew it or angle it, it's say plus or minus 10 degrees from the object you're trying to sense, it helps kill some of that reflectivity. So that may help you out as well from that standpoint, just to not get so much reflective light back into the sensor and get some of the nuisance trips. Speaking of which, that's if you look at the reflectors, they have a honeycomb pattern built into the reflectors. So if you could use a piece of mirrored glass as a reflector. But if you use just a mirror, you have to be perfectly 90 degrees to that sensor face to get all the light reflected back to it. Whereas if you look at that honeycomb pattern, it gives it many more reflective surfaces inside those reflectors, so it doesn't necessarily have to be 100% lined up with the sensing face to get functionality out of it. Laser light sources, this is another form of photo eye that's been out there, becoming more and more popular. Customers like it just because they can see the visible beam when they're lining it up. It aids in setup. From that standpoint, the one thing to keep in mind is it is a narrow focal point versus a infrared style photo eye. So if you've got objects, you may shoot clean through them if you've got a small hole and then a little bit harder to detect, where you, or a palette, you may see through the palette more so than you would with a wider angle or wider beam photo eye. Just something to keep in mind. But again, lasers, they work really well for long distances, but also keep in mind with that long distance, you have a really narrow, tight beam pattern. So it's just like a rifle or a gun. You have to have a fixed or steady mount, or you can be bouncing that beam all around and not be very steady once you add much distance to it. It's amplified. The other thing, for heavily contaminated areas, dusty environments, a laser may or may not be as well suited for that type environment. You just gets a lot more contaminated dust and things like that are reflected off that beam. You just have such a small focal point that it's bounced back into the sensor a lot more so than if it's spread out.